everyone, I am the professor, and in this video lecture we will be discussing more about number of factors. Before I move on to one example and try to differentiate how to find out odd and even factors and then check the number of factors that are perfect squares and perfect cubes and so on, I would like to make an observation which is very interesting. Let's see what happens when we try to factorize a number which is a perfect square, and what is so interesting about the number of factors a perfect square has. So the number of factors for a perfect square, let's see what happens. So I'll take a number like, let's say I'll take 36. Okay, so I know that the prime factorized form for 36 is 2 square into 3 square, right? 2 square is 4, 3 square is 9, 4 into 9 is 36. So this is a prime factorized form which I am very comfortable with. So, and I know that 36 is a perfect square, it's a square of 6. So let's see what are the number of factors for this number. So if I try to calculate the number of factors, I'll add a 1 to this 2 plus 1 and 2 plus 1 over here also, and then multiply. So it is 3 into 3, so there would be 9 factors for 36. Now let us take another perfect square and see what kind of a similar pattern or similar observation we can make. Let's take 49. So 49 is 7 square. 7 is itself a prime factor, so the prime factorized form would be 7 square itself. So the number of factors would be 1 more than 2, right? So I'll add 2 plus 1, which is 3. So 3 factors are available for 49. Okay, so I have found out number of factors for 2 perfect squares. Let's take one more to make our observation slightly more visible. So the example that I would take would be, let's take 64. Okay, or a better example would be 144. Yeah, 144 is another good number. So 144 is 4 into 3 square, or if I need to prime factorize it, I can write it as 2 to the power 4 into 3 to the power 2. So the number of factors for 144 would be 4 plus 1, 5 into 2 plus 1, that is 3. So 5 into 3, 15 factors are available for 144. So I know that all these three numbers are perfect squares. And what I have observed is that all the number of factors for all these three perfect squares are odd. So is it necessary? Yes, it is. For any perfect square, the number of factors has to be odd. That is for sure, because it would be raised to a multiple of 2, and whenever you add 1 to a multiple of 2, it would definitely result in an odd number because it would be of the form 2n plus 1, right? So that would make the number of factors for every perfect square odd. So that's an observation that we can make. So whenever we are given number of factors as odd, the number itself has to be a perfect square, or in case it's a perfect square, the number of factors for that number is odd. Number of factors for of a perfect square is odd. It has to be necessarily true always. So we need to remember this, because in questions when it is encoded, so this kind of a statement might be used where you need to infer that okay, it's a perfect square, so definitely the number of factors would be odd, or if there is a number that such that the number of factors for that number is odd, then it has to be perfect square. So that these kind of inferences is something that you need to make, especially while giving cat. These inferences are something that you'll come across quite often. Okay, so what I'll do now, I'll take another number and try to give you some more inferences that you can draw. That would help you ease and understand how such inferences work. So I'll take a number, let's say for example 6000. Okay, and I'll try to figure out the number of factors, then I'll move on to odd and even factors, then factors which are perfect squares, factors which are perfect cubes, and so on and so forth. So 6000, if I try to factorize it in the first place, let's take the power of 2. So it is divisible by 2, it is divisible by 4 because the last two digits are 0. By 8 also it is divisible because last three digits are 0 itself. By 16 I need to check and since it is 6000, it would be divisible by 16 also. By 32, I don't think so. Let's see if it is. I'll just add another 2 at the end if it is divisible by 32. So for now I know that for sure that it is divisible by the fourth power of 2, that is 32. Let's check by powers of 3. So it is divisible by 3. It is not divisible by 9, so only one power of 3 is a factor of 6000. By 5, there would be, since there are 3 zeros, definitely there are 3 powers of 5. In case you didn't get that, for the first power of 5 I check the last digit, for the second power of 5 I check the last 2 digits, for the third power of 5 I check the last 3 digits, and since all 3 are zeros, so definitely it is divisible by the third power of 5. So this is the factorized form of 6000. Now let us see what is the number of factors of 6000. So if I take the number of factors, so number of factors would be 4 plus 1 into 1 plus 1 into 3 plus 1. I guess this was something that we covered in the last lecture, and you all can very well understand how this plus 1 came, because there are 5 options available, which are 2 to the power 0 till 2 to the power 4. So we have 4 plus 1 because the fourth power, and we have added a 1, that is 2 to the power 0. So I got 5 into 2 into 4. 5 into 2 into 4, which is 40 factors. So there are 40 factors of 6000 in all. Now firstly I'll divide these 40 factors into two parts, which would be odd and even factors. So we all know that numbers are made of odd numbers or even numbers. There is no third category in that sense. So either the factors need to be odd or they need to be even. So 40, if I try to divide it as odd factors, so these are the number of odd factors, number of odd factors, number of even factors. Okay, so that is the first distinction and differentiation I'll make. So number of odd factors. For odd factors, I don't need a single 2. Even a single 2 in the factors will make that factor a even factor. So I need 2 to the power 0. Even 2 to the power 1 would give me an even factor, so I can take only 2 to the power 0. For 3 there is no restriction, 3 to the power 1. For 5 also there is no restriction, because any number of powers of 5 will always result in an odd number. So 5 to the power 3. So these are the available options or available prime factorization which I can do for calculating the number of odd factors. I can't take any, even a single power of 2. Only 2 to the power 0 is the option that I can take while I am calculating the odd number of odd factors, number of odd factors actually. So the options that I get are 2 to the power 0, which is only one option, 0 plus 1. 3 to the power 1, there are two options, 3 to the power 0 or 3 to the power 1. 5 to the power 3, I'll have 3 plus 1, 4 options. So 4 into 2 into 1, 8 factors are there which are odd. So the number of odd factors for 6000, it's 8. Now okay, we know that factors can be either odd or even. So I know the total number of factors are 40, and I have already calculated the number of odd factors, which was 8. So if I just deduct 8 from 40, which are the total factors minus odd number of odd factors, so I'll get 32 factors. So this 32 factors is nothing but the number of even factors available for 6000. There is obviously the other way also. I can do this prime factorization for even factors also. So for number of even factors, I need at least 1 2. The number of 2's should be at least 1. So I can take 2 to the power 1 till 2 to the power 4. So I can take 2 to the power 1, 2 to the power 2, 2 to the power 3 and 2 to the power 4. So any of these options are available for number of even factors. For 3, since I already have a 2, so any number multiplied by 2 will give me an even number. So I can take any options for 3, 3 to the power 0 as well as 3 to the power 1. For 5 also I can take all the options. So I have written 5 to the power 3 itself. So here I have only 4 options, which were 2 to the power 1, 2 to the power 2, 2 to the power 3 and 2 to the power 4. For 3 I have 2 options, and for 5 I have another 4 options, 3 plus 1, 4 options. So there are 16 into 2, 32 factors. which was the same result that we obtained while we were deducting the number of odd factors from total factors. Now that we have already done how to differentiate between odd and even factors, there are some more conditions that you might be given. Suppose the number of factors that are divisible by a certain number. So we'll take two such numbers and try to infer the number of factors with that sort. That would help you explain how to infer, how to calculate the number of factors when they are given, when the condition is such that it is divisible by such certain number. So if I say the number of factors divisible by 15. Another example that I'll take is number of factors. I'll take certainly a bigger number in this sense. So number of factors that are divisible by 150. Okay. So these two examples would help you understand how to calculate such number of factors. Okay. So number of factors that are divisible by 15. So 15 is made up of a 3 and a 5, right? So I know that the number of factors that the question is asking me should already have at least one 3 and at least one 5 in the number of factors in the prime factorized form. So for this sense, I can only take 2 to the power 4, 3 to the power 1 and 5 to the power 1 to 3. I can't consider 3 to the power 0. So I can take as many options available for 2 because that is not restricted. So I can take 2 to the power 0, 1, 2, 3, 4. For 3 I can take 3 to the power 1 because there has to be at least one 3. I can't take 3 to the power 0. For 5 there has to be at least one 5, so I have to take 5 to the power 1, 5 to the power 2, 5 to the power 3. So the number of options that are available are 4 into 1 into 3. So there would be 12 factors. There would be 5 options available for 2, so there would be 5 into 3, 15 factors that would be available. Okay. Yeah, 15 factors available which are divisible by 15. So there are 15 such factors which are divisible by 15. Now calculating number of factors divisible by 150. So 150, if I try to prime factorize 150 itself in the first go, it is divisible by 2, not by 4. It is divisible by 3, not by 9. So 1 power of 3, by 5 also, by 25 also. So 2 powers of 5. So that is the prime factorized form for 150. So the number of factors that the question is asking me should definitely have at least 1 2, at least 1 3 and at least 2 5s. So this is the minimum condition required for calculating the number of factors. So I can take 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. Remember, I can't take 2 to the power 0 because there has to be at least 1 2. For 3, I can take 3 to the power 1, not 3 to the power 0. For 5, I can take 5 to the power 2, 5 to the power 3. I can't take either 5 to the power 0 or 5 to the power 1 because there necessarily has to be at least 2 2's present in this condition. So there are 4, 1 option and 2 option. So there would be 8 such factors that are divisible by 150. So the number of factors divisible by 150 of 6000 would be 8. Now that we have done another 2 conditions, let's move on to the last kind of conditions that we may be given. So the conditions would be number of factors that are perfect squares and number of factors that are perfect cubes. So number of factors that are perfect squares and number of factors that are perfect cubes. Okay, so these are the 2 last conditions that can be provided when you are dealing with questions of number of factors. So let us try to understand how do we deal with such conditions. So any factor that would be a perfect square, the prime factorized form can only have even powers, or the multiple of 2's should be the powers of that prime factorized form. So when we are considering number of factors that are perfect squares, I can take options. For this example only I'll consider. So I can take options 2 to the power 0 because 1 is a perfect square, 2 to the power 2 because 4 is a perfect square. Another option that I can take is 2 to the power 4 because 16 is another perfect square. I can't take 2 to the power 1 because 2 is not a perfect square. Neither can I take 2 to the power 3 because 8 is also not a perfect square. While I'm considering 3, I can just take 3 to the power 0 because 3 to the power 1 is not a perfect square. For 5 I can take 5 to the power 0 and 5 to the power 2. So these two options for 5, one option for 3 and 3 options for 2. So it would be 3 into 1 into 2. 6 factors are perfect squares. Number of factors that are perfect square of 6000 is 6. Now considering number of factors that are perfect cubes. So for cubes, similarly as we did for perfect squares, the powers had to be multiples of 2. For perfect cubes, the power have to be multiple of 3. So I can take 2 to the power 0, 2 to the power 3. I can't take beyond that because 2 to the power 4 is not a perfect cube. 2 to the power 2 or 2 to the power 1 is also not a perfect cube. For 3 I can take 3 to the power 0 because 3 to the power 1 is not a perfect cube. For 5 I can take 5 to the power 0 as well as 5 to the power 3 because both these options are perfect cubes. So I have the number of options. If I take I have two options of 2, one option for 3 and two option for 5. So there are 2 into 1 into 2, 4 factors. Number of factors that are perfect cubes of 6000 is 4. So that is about how you deal with number of factors when you need to find out the number of odd factors, number of even factors, when they are divisible by a certain number, or if they are perfect squares or perfect cubes. So that's about this video lecture. Thank you for watching. Keep studying. Stay safe. I am the professor. See you. Bye bye.